The leading edge in XRD imaging and technology, On-Site Technology USA presents two-dimensional, real-time Axis TAS-25 mounted on an expert analytical system. Here's data from XRR, X-ray reflectivity. And this is a omega only scan. You'll see the main beam that is invariant. That will be right at the center. This is a grayscale image, and I will contrast it with a pseudo color image. I'll show you the additional sensitivity that's involved. You can see the angle, the omega angle that is being changed. The incident beam is invariant, and you can see the reflected beam, the total internal reflection, moving away from the incident beam as the sample is being rocked through the omega. Detector is fixed. The two-dimensional detector is fixed. Here's a pseudo-color rendition. I will go into further narration of the items. This is again not a coupled symmetric, but a omega decoupled scan, omega only decoupled scan. Once again, you see the pseudo-color image of the main beam in the center. There's a lot of spots on the side, and we're investigating the origin of those. Potentially Unida spots, and you can see the total reflected beam moving away from the main beam, and the detector is fixed at 135-degree sample to detector distance, which covers about 7 degrees, 6 to 8 degrees to theta. Here's a comparison of various regions of interest chosen for the profile, and it's very interesting how the profiles are directly affected by the region of interest choice, which is tantamount to the choice of slit sizes in conventional diffractometry. This is a integrated image of the Unida spots. This is a grayscale peak shift map for the entire two-dimensional field of view. You can see the incident beam to the left and the diffracted beam to the right. Here is a image of the omega Y-omega scan, and now we're going into the NIST 2000 XRR analysis. This was done on a Brooker D8. You can once again see the incident beam and the diffracted XRR total internal reflected beam. This is the Y-omega scan, and here's a comparison between the Panalytical and the Brooker. Now, the comparison of the data from the Brooker with the simulated data from Leptos was a near perfect fit. And here's a comparison of the NIST sample with the platinum thin film on silicon. Contact us if you want to have the same advantage in your lab. Here are the details. Best wishes.